We are on chapter 3, section 3.1, graphing equations, and our first objective today is to plot ordered pairs. First, let's have a look at some definitions. Ordered pair are two numbers associated with a point. So the first number gives you the horizontal location of the point, and the second number will give you the vertical location of the point. Another definition is coordinate. Is a number in an ordered pair, and since you have two numbers, the first one is going to be the x coordinate and the second one is going to be the y coordinate. X-axis, well, you have two axes, x and y. X is the horizontal number line and y is the vertical number line. And a few other definitions. We have also the origin, which is the point of intersection of these two axes, x and y, and the quadrants, which are the four regions created by the intersection of the two axes. Okay, now to graph the points corresponding to a particular ordered pair, you must start at the origin. So you start at the origin, 0, 0, x equals 0, y equals 0, and you move x units to the right or to the left, depending on the sign. If it is positive, you go to the right. If it is negative, you go to the left. Then you're gonna move y units up or down. Up if y is positive and down if y is negative. So let's have a look at a few examples so we can understand it. First, let's have a look at this point here, which is the origin. Here is the origin because it's the intersection of x-axis and the y-axis, right? And the coordinate at the origin is always going to be 0 and 0. X equals 0 and y equals 0. Let's say we have this ordered pair, 5 and 3. How do you plot this ordered pair on the graph? The first, you're gonna get this point here, this number here, which is the x coordinate. And the x coordinate, you're gonna start from the origin and you're gonna move 5 units to the right. 1, 2, 3, 4, 5. Now you go to the next point. The next point is the y coordinate, which is going to be 3, y coordinate. And the y coordinate is positive, so you go up. 1, 2, 3. And this point here is going to be associated to the ordered pair 5 and 3. So this point is the coordinates of this point is this ordered pair 5 and 3. Let's have a look at a few other points. If we have, for instance, -4, -4 and 2. Let's plot here. 1, 2, 3, 4. This is -4 to the left, right? And 2. +2, 1, 2. This is 2. So this point here have the coordinates -4 and 2. This point is associated with the ordered pair -4 and 2. Another point. Let me erase this. Another point we will plot on the graph is 2, -4. So the first one is the x coordinate, so we go to the x-axis and we move 1, 2 to the right, because it's a positive number, right? And then -4 is the y coordinate, -4, let's move 1, 2, 3, 4, -4, and this point here is going to be the point associated with the coordinates 2, -4, the order pair 2, -4. Note that the order of the coordinates is very important, since, have a look here, -4 and 2 is this point, and 2 and -4 is a totally different point. Let's quickly have a look at some other points, and now we go faster because we already know how to plot the points. 0 and 5. So 0 is from the origin, we don't move neither to the right nor to the left. Then we move 1, 2, 3, 4, 5, and the point 0 and 5 is here. This is the point associated with the order pair 0 and 5. Another one, -6 and 0. Okay, we go here to the x-axis and we move to the left from the origin. 1, 2, 3, 4, 5, 6. -6 and 0. 0 means we're not moving neither up nor down, and the point is right here, -6 and 0. Remember the quadrants. This here is the first quadrant, that is the second quadrant, that one is the third quadrant, and here you have the fourth quadrant. Don't forget that each order pair corresponds to exactly one point in the plane, and that each point in the plane will correspond to only one order pair. Now a few points that you can work by yourself, and you can pause the video, try by yourself, and then when you finish you play the video again. Pause now. Now let me show you how to plot, where to plot these points. Let's check if you did a good job. First one, 4 and 2. So from the origin, walk 4 to the right and 2 up. This is the order pair 4 and 2. This is the point associated with the order pair 4 and 2. Next one, -3 and -2. From the origin we move -3 is 3 to the left, 1, 2, 3, and -2 is 2 to down. So this is the point associated with the order pair -3 and -2. Another one, 2 and -3. So from the origin move 2 to the right, 1, 2, and -3 is 3 to the bottom, 2, 3 down, 3. This is the point associated with 2 and -3. Now 0 and 4. 0 means we don't move neither to the right or to the left, and 4 is the y coordinate, we move 4 units up, and this point here is the point corresponding to the coordinates 0 and 4, or the order pair 0 and 4. And now 5 and 0, from the origin move 1, 2, 3, 4, 5, and you're not going either up or down because the y coordinate here is 0. So this is the point here associated with the order pair 5 and 0. And check if you did a good job plotting the points on the graph. Next, the second objective, to determine whether an order pair is a solution of an equation. And let's go straight to this example. Determine whether 3 and -2 is a solution of 2x plus 5y equals -4. So this is the order pair, 3 and -2. That means x equals 3 and y equals -2. We will then plug in these coordinates, these values, on the equation. So 2 times x, x is 3, plus 5 times y, y is -2, equals -4. After we plug in, we will simplify and check if this equation produces a true statement. So we can see if it's a true statement, this order pair is a solution. So let's check it out. 2 times 3, 6, plus 5 times -2, -10, equals -4. 6 minus 10, -4, equals -4. And this is true statement. What means that x equals 3 and y equals -2, or this order pair here, is a solution of this equation. Right, next example. Determine whether the order pair -1 and 6 is a solution of 3x minus y equals 5. So let's work this out. X equals -1 and y equals 6. Plugging on the equation, 3 times x, -1, minus y, 6, equals 5. And 3 times -1, -6, -3 minus 6 equals 5. -3 minus 6, -9 equals 5? I don't think so, right? This is false. This is false. That means this order pair is not solution of that equation. Now let's move to third objective, which is graphing linear equations. A linear equation in two variables is an equation that can be written in this form, and a is a real number, x is the variable, plus b is another real number and y is the variable. A and b must be different from 0, and C is another real number. This is the standard form. Graph the linear equation y equals 3 over 4x plus 3. The thing that we're gonna do to graph at this point, we will find 3 different points. Find 3 different points. How you're gonna do this? By assuming a value for x and finding y. First value that we're gonna assume for x, you can assume any value that you want. This is what I usually do. I usually try as the first value 0. And then you're gonna find y equals 3 over 4 times 0 plus 3, right? That means y equals 3. Then this is going to be your first order pair. Let's write down here. Let's get a space here, and this is going to be our first order pair, 0 and 3. Next value that I will assume for x, I will assume here, since there's this denominator 4, I will assume x equals 4, because when I calculate here y equals 3/4 times x 4 plus 3, then I can simplify. See, simplify, and we will have y equals 3 plus 3, 6. So we have a new order pair, 4 and 6, and we have 2 order pairs. Now let's find another order pair that relates to this equation here. Let's guess now. X equals, as I told you, you can assume any number, but let's try to work with numbers that will give us an easier way of graphing, preferably integers, right? So 8, let's try 8, or we can do instead of 8, negative 4. Negative 4 is a good number. So y equals 3 over 4 times negative 4 plus 3. We can simplify, and we have 3 and negative 3 plus 3 equals 0. Now we have another order pair, negative 4 and 0. Okay, and we can now graph our go to our coordinates, go to our x and y axis, and here we have the order pairs that we found. And let's plot these order pairs on the graphic. First one, 0 and 3. 0. We start here, and then we move 1, 2, 3 up. 1, 2, 3, 3 up. Okay? So this is the first order pair. Next one, 4 and 6. 1, 2, 3, 4. And then we move up. 1, 2, 3, 4, 5, 6. The second order pair. Okay, now -4 and 0. So move 1, 2, 3, 4 to the left. This is -4 here. 4, 0, and then 0. Not moving neither up or down. And we have 3 points. They are nicely aligned. And we can connect these 3 points with a line which will be our graphic, our linear equation, the representation of our linear equation. Very good. So we've done our first graphic. Let's see the next example. Now we have another linear equation, 2x minus y equals 4. Remember, what would we do? We will assume values for x and find y. So let's say we will assume x. I always try x equals 0 first. That's up to you, but I always like to assume x equals 0. And then we will have 2 times 0 minus y equals -4. If you simplify this, you're gonna find that y equals 4. And this, let's do here on the top. Is our first order pair, 0 and 4. Okay. Next one, we can assume here x equals 1. So 2 times 1 minus y equals -4. Here we have to simplify, subtract 2 from both sides. -y equals -6. That means y equals 6, right? So this is the second order pair that we have, 1 and 6. And another one, another value for x. Let's assume x equals, we can guess here 2 or -1, whatever you find more interesting. Okay, let's work with -1. Two times -1 minus y equals -4, right? We're plugging the x on the equation. The result here is going to be, well, we're going to have 2 times -1 is 2 times -1, -2, right? So we have to add 2 on both sides. If we add 2 on both sides, we're going to have, let's move this a little bit upwards so we have more space. Great. We have -6 y equals -4 plus 2, -2. That means y equals 2, right? If we divide or multiply both sides by -1. Great, now we have the third order pair. The third order pair is going to be -1 and 2. Great. Let's get all the order pairs that we found. Copy the order pairs, and now let's go to the graphic. let's plot the first one. 0 and 4. So start here from the origin, and don't need to move neither to the right or to the left, because 0, right? And go up 1, 2, 3, 4. 4. Next order pair, 1 and 6. So x equals 1. 1 is here. And y equals 6. 1, 2, 3, 4, 5, 6. Great. And next one, -1. Go to the origin, starting from the origin, go to the left. This is -1. And 2. You're going up 1, 2. 2 is here. This is our third order pairs. 3 points nicely aligned. So get now the ruler and make your line representing the equation, the linear equation. Don't forget the arrows. These arrows here mean that this line goes all the way to infinity from both endpoints, from both sides, I mean from both directions. And this is our graph. A helpful hint here, when you're graphing a linear equation in two variables, it is solved for y, may be easier to find order pair solution by choosing x values. If we solve it for x, it may be easier to find order pair solutions by choosing y values. So we've done assuming values for x, but you can also do the same thing, assuming values for y and finding x. Another helpful hint: if the graph crosses the x-axis at 2 and 0, and then the y-axis at 0 and -8, then 2 and 0, this order pair here, is the x-intercept, and 0 and -8 is the y-intercept. That means this point here is where the graph intercepts the x-axis, and this point here is where the graph intercepts the y-axis. Sometimes you may see just the number -8 as the y-intercept and 2 as the y-intercept. We usually, during our course, we represent the order pair, but sometimes you can find just the number to say this is the y-intercept and this is the x-intercept. Okay. To find x and y-intercepts, what do we need to do? First, to find the x-intercept, you're gonna let y equal 0 and you solve for x. And to find the y-intercept, you're gonna let x equal 0 and solve for y. And let's see an example here. Well, if you have, and this is an interesting example, if you have 2x equals y, find the y-intercept and find the x-intercept. What should we do? Well, to find y-intercept, what we're gonna do is let x equal 0. Now we plug x equals 0 into the equation. That means 2 times 0 equals y. and this results y equals 0, right? 2 times 0, 0, y equals 0. And what about the x-intercept? This x-intercept, you have to assume y equals 0, plug y equals 0 into the equation, 2 times x equals 0, and find y, and find x. At this point here, you find x equals 0. And in this particular equation here, for this particular equation, the x and the y-intercept, they are at the same point. They are at the origin, 0 and 0. Right? They are both x-intercept and y-intercept. They are 0 and 0. Now that's kind of a problem here to solve this question, because we need to graph the equation. We just have 1 point. We don't have 2 points, right? We just have 1 point. Now we need to have, it's good to have at least 2 points, but usually you have to work with 3 points, just to be sure, just to make sure that you're doing the right calculations. So let's get the equation again here, and let's assume other values for x. Let's say x equals 1, then 2 times 1 equals y, y equals 2. And let's assume here x equals 2, or x equals 3, or x equals 4, whatever you find better for you to work out the graphic. I'm assuming here x equals 2. 2 times x, 2 times 2 equals y, y equals 4. Now we have 3 points, 3 ordered pairs. We have, let's write down here on the top, we have 0 and 0, we have 1 and 2, and we have 2 and 4. Let's get these 3 ordered pairs here, oops, and now we can go to the graphic and plot these ordered pairs. The first one is the origin, 0, 0, origin 0, 0 here. Okay, next one is x equals 1 and y equals 2. 1 here and 1, 2. And another one, x equals 2 and y equals 4. 1, 2, 3, 4. And the 3 ordered pairs are perfectly aligned. Get the ruler, and now you can connect your ordered pairs and represent your linear equation. Now you having the 3 points, you can graph your linear equation. Graphing non-linear equations. This is objective number 4. To graph non-linear equations, we need to work out this on this table, and we need to assume more values for x. Remember that we've assumed for linear equation 3 values for x and found y. Now we're gonna we're gonna assume more values for x, 5, 6 values for x, and plot to find the graphic of a nonlinear equation. Alright, here we are assuming x initially -2. If x equals -2, we plug in the equation y equals -2 squared. -2 squared is 4. Next one, x equals -1. Let's plug in the equation. X equals y equals -1 squared. -1 squared is 1. Now 0, plugging in the equation, 0 squared is 0. Now 1, do the same thing, plugging in the equation, 1 squared is 1, and finally 2. 2 squared, 2 squared is 2 times 2, 4. Now we go to the order pairs. So we have -2 and 4, -1 and 1, 0 and 0, 1 and 1, 2 and 4. We have 1, 2, 3, 4, 5 order pairs. It might be sufficient to have an idea of this graphic. Let's start with this one, the origin. 1 and 1. X equals 1, y equals 1. Next one, 2 and 4. X equals 2 and y equals 4. -1 and -1. This is okay. -1 and -1. And 1, I mean. -1 here and 1. And -2 and 4. -2 is here. 1, 2, 3, 4. 4 is here. And let's try carefully here to draw the graphic, which is going to be a parabola. The arrow. This side here is not so nice. Let's try again. And don't forget the arrows to indicate that this graphic here goes all the way to infinity. Great. Next one, another nonlinear equation that we will graph. Now is absolute value. Y equals absolute value of x. If x equals -2, absolute value of -2 is 2. X equals -1, absolute value of -1 is 1. 0 is absolute value of 0 is 0. 1 absolute value is 1, and 2 absolute value is 2. Let's plot here. 0 and 0, 1 and 1, 2 and 2, -1 and 1, -2 and 2. And this graph is going to be something like this. And don't forget the arrows. So this is the graphic of the absolute value equation. Another graphic here, and now is y equals square root of x. Square root of 0, 0. Square root of 1, 1. Square root of 4, 2. Square root of 9, 3. And let me ask you something. What's the square root of negative 1? No solution, right? No solution on the real the set of real numbers. No real solution. Negative 2, no real solution. So here on the negative sign of the x-axis we will have no representation, no graphic at all. This graphic starts because you cannot have a square root of negative numbers. So you start your graphic here on the origin, 0 and 0. Now 1 and 1, 2 and 4. I mean, let me fix this though. 1 and 1 here. X equals 4. 1, 2, 3, 4. And y equals 2. Here. Okay. X equals 9. 9, 6, 7, 8, 9. It's somewhere here. 9. Y equals 3. 3. And this graphic is half of a parabola. Laying down. Goes all the way to positive infinity, but stops here. Doesn't include the negative side of the x-axis or the y-axis. Alright, this is we ended section 3.1. Now we are ready to move on to the next section.